Definition, let's repeat the definition of relation. Relation is nothing but on set A, you take the Cartesian product of set A cross A. For example, this is you take A cross A, you get this set. In this, you take a subset, you get relation based on some pattern. And for two sets, if you have set A and B, same thing you will do. You take A cross B, and from this you take a relation based on a pattern. Correct? The same formula which we repeated. Here, what I am saying is a relation R on set A is called universal relation if each element of A is related to every element of A. That means all the elements of A cross B fits the criteria. For example, these are the girls, and I say the difference between age of A and B is less than 100 years. Please note, it is less than 100 years. Now, you take any two girls. You take girl 1, you take girl 2, 3, 4, 5, 6, let me number them. You take any two girls, you take 1 and 2. You will find them the difference between their age has to be less than 100 years. Why? Because they are all school girls of class 10. And let's suppose I'm writing their age. So let's suppose this girl is 16, this is 17, this lady is 18, this is 16 again, this is 15, and this is again 17. Age of this girl. So if you take any two girl, the difference in their age will be less than 100 years. If you take these two girl, the difference is 1 year. These two 1 year, these two 2 years, this two 1 year, this two 2 years. So if you take any two girls, the difference is always less than 100 years. So if you see, now if I take the Cartesian product A cross A, whatever element comes, that is with 1 I'll get 1 2, 1 3, 1 4, 1 5, 1 6. Similarly with 2 I'll get, right? 2 I'll get 2 1, 2 2 2, 3, 2 4, 2 5, 2 6. All the elements, in fact 1 1 is also part. So 2 1, this 2. Similarly 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. Similarly 5 1, 5 2, 5 3, 5 4, 5 5 and 5 6. And with 6 lady, I'll get the pairing with 1 first, 6 with second, 6 with third, 6 with fourth, fifth, and 6 with sixth. So I have this many values I'll get. This complete is nothing but A cross A. And if you see all these values here will satisfy this condition. Age of 1 and 1, difference is less than 100 years. Why? Because this is 0, the difference is 0. 1 and 2, difference is 1 year, so this is fine. 1 and 3, difference 16 minus 18, 2 years. 1 and 4, 1 and 4 is again 0 years. 1 and 5, 15 and 16, 1 year. 16, 17, 1 year. So if you see all these values, if we count all these values, satisfies this relation. Correct? So here if you see this relation, the objects in this relation are nothing but A cross A, all the elements. So this is called universal relation. In the early example, when I say the same thing, instead of less, if I make it more, this becomes empty relation. Why? Because any two objects, if you compare, the difference in the age is not more than 100 years. It is always less only. Correct? That is the difference between universal relation and empty relation. First, try to understand. First thing you have to do is you have an object or you have a set. So if you have one set, you get A cross A. You get this values, and then you define a relation, a pattern. If that pattern will take all the objects here, for example, the pattern was A and B age is less than 100 years. If it takes all the object, it is universal relation. If the pattern which you define takes none of the object, then that relation is called empty relation. For example, when you say the difference in the age is more than 100 years, or you say A is the brother of B. In that case also, none of the object, none of the values here will satisfy the condition, so that will be empty relation. So we know what is empty relation and what is universal relation. Trivial relation is nothing but both empty relation and universal relation are sometimes called trivial relation. Just a terminology, just good to know that trivial relation is nothing but Empty relation, universal relation, both are called trivial relation.